Hello student of class 8, once again I am Sudhi and welcome back to my video. In today's video I will start a new chapter, that is chapter number 11, and name of the chapter is mensuration. So in this chapter we are going to study about finding the perimeter and area of different figure called geometrical figure. So we have studied about different type of figure, as you call the rectangle, square, polygons, quadrilaterals. Many goals are there, isn't it? Yeah. So there we are trying to find out the perimeter and area of such figures. So this chapter will teach us how to find the perimeter and the area of certain figures. That also may be a certain figure that is different from our regular figures. Okay. So let us start the class now. So in the part of introduction, I just give some observation like this. We have learned that for a closed plane figure, the perimeter is the distance around its boundary and its area is the region covered by it. We found the area and the perimeter of various plane figures such as triangles, rectangles, circle, etc. We have also learned to find the area of pathways or borders of rectangular shapes. In this chapter, we will try to solve problems related to perimeter and area of other plane closed figures like quadrilaterals. We will also learn about surface area uh, and volume of solids such as cube, cuboid, and cylinder. Once again, we will also learn about surface area and volume of solids such as cube, cuboid, and cylinder as the latter part of the chapter. Now, to begin with, so I will show you one uh, diagram here. In this diagram, we will remind together of some of the formulas to find out the area of some plane figures. So here we go. You can see that the table is giving you of some diagram and the name of the shape and area of it. The area is not matching. So we are going to match the area according to the diagram given here or according to the name of the shape given here. You can see the first diagram is rectangle. The first diagram is rectangle and area of the rectangle, as you know, it is A into B. Since A is the breadth and the B is the length, so it is A into B. Okay, or B into A, doesn't matter. Then next we have another figure called square, and the area of the square, you know that the side is A, so it is A into A. Got it. Then next we have triangle. The area of the triangle, you know that it is half base into height. Okay, so you can see one dotted line here in the figure, that is height of the triangle, and the below line is the base, so it is I mean the area of this triangle is half base into height. Okay, and next we have the figure called parallelogram. That the parallelogram also can find out the area by using this formula, that is base into height. B stand for base and H stand for height. But here, this in this all the diagram, all the diagram is given B, V, V here. So V stand for a part of the figure called length. Okay. Then next we have another figure called circle. So in this circle, you can see that the radius is replaced by B. So in this case, the area of this circle is pi r square. I mean pi b square. Actually, it is pi r square. R stands for radius, and pi is uh, Greek letter. It's from Greek letter, and it has uh, a unique and constant value, that is 22 by 7, or yeah, 22 by 7, or it is 3.14, okay, approximately. So there's trend. Now we have already know that the area of some of the plane figure now. Then this is the area of this plane figure, but can you find out the perimeter of the above shape? If you are able to do, please try, and if you are not really uh, aware of this perimeter, then you can ask me at any time. Okay. So with this, let us start the next part of the chapter. It is exercise 11.1. So we'll start the exercise 11.1 very soon because uh, there is not much things to be discussed on, because we have already come across how to find the area, how to find the perimeter of any set, isn't it? So let us start with the exercise now. Here we have question number one. In the question number one, it says like this: a square and a rectangle filled with measurements as given in the following figures have the same perimeter. So which has a larger area? So you will have the diagram here. There are two diagram A and B. A is square and B is a rectangle. And by the question, it says that if you uh, if you find uh, if you find the area of these two, so which one will be the greater area? And of course it says that the perimeter are same. Okay, the perimeter of these two figure A and B are same, and asking you that uh, to find out the area, and also asking to find out whose area is large. Okay. Now in the solution, let x be the breadth of the rectangle, and it is given that the perimeter of the rectangle is equal to perimeter of the square. It is given by the question itself, isn't it? So you see, my dear student, to find out the area of the square, it is okay, because one side is enough to find the area of the square. But in the rectangle here, in the rectangle, what happened? We need to find out the breadth also. We need the breadth to find out the area, isn't it? Because area of the rectangle is length into breadth. So breadth is not given. So this breadth is unknown. So let us take this unknown value of breadth as x. X be the breadth of the rectangle. And also it is given that the perimeter of the rectangle is equal to perimeter of square. Now by the question we have like this. Therefore, perimeter of the rectangle is, you know that perimeter of the rectangle implies that, okay, implies that perimeter of the rectangle is 2 into L plus B. So L is the length and B breadth is not given, so we take as X here. Since we have already mentioned here to take X as breadth, isn't it? So perimeter of the rectangle is length into 2 into L plus B, and 2 into L plus B. So this perimeter will equal to the perimeter of the square. That is, perimeter of the square is 4 into side, isn't it? So 4 into side. Side is 60 meter here, isn't it? And next we have 2, yeah, 2 into, yeah, 2 into 80 is equal to, yeah, yes, we have. So once again, this one we have here that area perimeter of rectangle 2 into L plus B equal to perimeter of the square 4 into side is 4 into 60, isn't it? Then next we have like this. We just keep this 80 plus x on this side, and 2 if we bring here, then 2 will divide this 4 and will become 2 here. So 2 into 60 120. In that way you can find, but one step is been one step has been skipped, isn't it? So this 2 will divide here. So actually it is 200, sorry, yeah, 240. So 200 to 240, if you divide 240 by 2, you will get 120, isn't it? Yes. So next step we have 80 plus x equal to 120, and then x is 120 minus 80, that is 40. So we get the breadth of the uh, rectangular field. Breadth of the rectangular field as 40 centimeter. Yes, that is breadth of the rectangle is 40 meter. I mean, yeah, 40 meter. Then next, what we are going to do is now the area of the square. The area of the square, you know that area of the square. How to find out the area of the square? Area of the square is side into side, isn't it? 60 into 60 meter. That is 3,600 meter square. So this is a meter square. Okay, not meter two. Meter square. So 300, 300 and so now we get the area of the square. The area of the square will be 16 to 16 meter. That is 3600 meters square. This is the area of the square now. Now area of the rectangle. Since we get the breadth of the rectangle, we can find out the area of the rectangle. It is length into breadth, isn't it? So length we get 80 meter and the breadth we get 40. So these two have to be multiplied, isn't it? So after multiplying these two, we get here uh, 8 fours are 32, isn't it? Yes, 8 for 32 and 2 zeros, yes. There is 3200 meters square. So now the area of the rectangle as 3200 meters square and the area of the square as 3600 meters square. So who is greater the area now? The area is greater by square field, isn't it? So we got the final answer, hence the square field has a larger area. So this is the answer for question number 1, and let's go to next question now. Next question number 2. In question number 2, we have the question like this. Mistress Kusik has a square plot with the measurement as shown in the figure. She wants to construct a house in the middle of the plot. A garden is developed around the house. Find the total cost of developing a garden around the house at the rate of rupees 55 per meter square. So we are going to find out the area of the garden first, isn't it? But the whole plot has given here. From the whole plot, we are going to find out uh, the total area of the field. Okay, so let us see the figure here. So this is the figure of the plot of Mrs. Kusik. Then Mr. Kusik has this plot. So here you see he used to make the garden around the house like this. Okay, around the house. This is the house, and the total plot is given here. This plot is having 25 meter on both the side, here also, isn't it? Now we are going to find out the total area of this garden here. So what we have to do is that we have to find out the area of the total plot and the area of the garden, and if we subtract the area of the house, okay, area of the house from the total area of the plot, then we'll get the remaining area where she developed the garden. Okay, develop the garden. Then let us see next. In solution, area of the garden is equal to area of the outer space minus area of the inner rectangle. Area of the outer space means we have to find the area of this the whole plot and minus the area of the uh, inner rectangle. So uh, two area you can find the area of the total plot and the area of this rectangular shape where the house is made. Okay, now let us see. There is area of the outer space. There is 25 into 25. The it is already mentioned that the total plot is in the square shape. The square shape. So area of the square is side into side. That is 25 into 25. 25 into 25. It means that area of the square, isn't it? Then minus area of the rectangle, rectangle area. So rectangle length is 20 meter and the breadth is 15 meter. So we have to multiply. So next we have uh, here the answer is 625 of the area of plot. Okay, area of the plot is 625 and area of the house, area of the house, region where the house is there is 300. So we minus it and we got here 325 325 325 meters square. 325 meters square is the uh, area to develop the garden. Now we are going to find out the total cost of the area for the garden to develop. Means in developing the garden, how much that total cost is. Okay. Now cost of developing a garden at the rate of rupees 55 per square meter. We have rupees 55 into total area of the garden. There is 325 meter square, isn't it? The meter square is not required here to find out the cost, so we need only the figure here. There is 325. So 55 into 325, we are getting here 17,875 after multiplication. Okay, so this is the answer. Then we find out the total cost of developing the garden from the plot. Okay. So here we have the answer for question number 2, and let us go to the next question. So next question, we have question number 3. In question number 3 it said that the shape of a garden is rectangular in the middle and semicircular at the ends shown in the diagram. Find the area and the perimeter of this garden. So length of the rectangle is 20 minus 3.5 plus 3.5. 3.5 is just that much distance made by the semicircle. So you will learn here. So here is the diagram. So this is the diagram of rectangular garden. Okay. So what happened is rectangular in the middle and semicircle at the end. You see. So the question is asking you to find the area as well as the perimeter of the garden. Perimeter and area of the garden. So perimeter will be the total length of this boundary, and area will be the area of the rectangle and as well as area of this semicircles. If you add, you will get the area of the garden, the total surface, isn't it? So one condition is given here, that is length of the rectangle will be 20. This from this part to the another end part, the whole length is 20 meter, but the length here for the rectangle is not 20 meter. It should be subtract 3.5, another 3.5. 3.5 is the space or the gap between the point here and the point at this semicircle. Okay, the gap you can see here in the semicircle is about 3.5 meter. That means the radius of the semicircle is 3.5. Understand? One 3.5 from here, another 3.5 from here. Then you subtract this both from 20, then you will get the length of the rectangle. That you have to keep in your mind. Now let us go to the solution. In the solution, total area of the garden is equal to the area of the rectangular portion plus sum of the areas of the pair of semicircles. Pair are there, means two are there, isn't it? So we have to add these two as well as the area of the rectangle. Then you will get the total area of the garden. Yes, we know. Now let us see. That means the area of the rectangular portion will be 13 into 7. 13, from where we get the 13? That means 3.5 means we will get 7 here. 7 minus 20 we will get 13. The length we will get as 13 here. Then we are in this 13 here. And in breadth you had given here, this is the breadth. That this line or this line will be 7 meters, isn't it? Therefore it is 13 into 7 meters square now. And the sum of the area of the two semicircle here. So 2 into uh, half of the area of the circle. Area of the circle is pi r square. Area of the circle is pi r square. So pi r square, this is pi, and r square means r radius. So radius, we have already got this radius as 3.5, means half of the 7. This is 7, isn't it? This is 7. So my dear student, again you see, as the length of the line here is 7, and this will be the diameter of the circle here. So diameter of the circle is the 2 times of the radius, means radius will be the half of 7 will be 3.5, and from this point up to here also will be the radius, isn't it? When the radius is 3.5, as it is the half of 7 meter, then the gap here also will be the same as the radius, and that means 3.5. That's why we have to subtract 3.5 again and again from 20, so that we get here 13 meter, isn't it? So next is plus 2 times the area of the semicircle. 2 times the area of the semicircle. So here you see 2 into half. Semicircle means half of the circle, isn't it? So area of the semicircle is half of the semicircle, half of the area of circle. So 2 into half. Half means because of the semicircle, and this is a value of pi. Okay, 22 by 7 is value of pi, and r square means r radius is to 3.5. So r square 3.5 into 3.5, isn't it? So from here you see this 2 and this 2 will be cancelled. No more 2 again. You got here 22 by 7 into 3.5 here, isn't it? This part is already finished. We got 2 and 2, we cancel it, isn't it? Then 22 by 7 into 3.5 into 3.5. See, if you cancel 7 and 3.5, you will get here 0.5 here. 7, you can 0.5. 7 over 7 is 0.5. You will get here 3.5, isn't it? So 0.5 and 3.5, if you multiply with 22, you will get here 38.5 here. 38.5. Once again, 2 and 2 will cancel. You get here 22 by 7 into 3.5 into 3.5 only. This part only you are going to calculate. So this 7 and 3 can be cancelled. 3.5 can be cancelled. So 7 on 7, 7 0.5. Okay, 1 will become 0.5. So 0.5 and 3.5, if you multiply together with 22, you will get 38.5 here. So this 91 is from this multiplication of 13 and 7 here, which is the area of the rectangular portion, isn't it? So altogether, if you plus these two, you will get 129.5 meters square. So this is the total area of the garden. Now we got it. Okay, we got the total area of the garden. What we are going to find out is the perimeter of the garden. So perimeter of the garden is twice length of rectangular portion. Twice length of the rectangular portion. 1, 2, and circumference of the circle. Okay, circumference of circle. See, uh, yes, my dear student, you see here it did not mention one thing, that is yeah, it's okay. Now we have this two times the length of the rectangular portion. Rectangular portion here, from here to here is 13. We have already got 13 because this part, if you subtract, we got 13. 20 is the total length of the garden, but uh, rectangular portion, the breadth will be 13 after subtracting 7, isn't it? So here 2 is a just we have 2 1 2 here, length here, no, one length here, another length, isn't it? And this semicircle, isn't it? Semicircle. Okay, that means 2 into 13 plus semicircle of the circle. Okay, circumference of no semicircle, I'm sorry, circumference of the circle. Semicircle here, see, one semicircle got the one circle, isn't it? Form one circle, isn't it? So if you get the circumference of the circle and two times of the length, then you will get the perimeter of the garden. So perimeter, sorry, the two times of the length, 2 into 13, and circumference of the circle is twice pi r, twice pi r, 2 pi r. So 2 pi, so this is the pi value, isn't it? 22 by 7, and r is the radius is 3.5. So we got the radius 3.5. Okay, this is the, once again, the whole length is 7 here, and this is the diameter of the circle, so radius will be the half of it, it is 3.5. So like this, we are getting here that 26 plus 22. How 22 is that? If you cancel this 7 and 3.5, you will get here 0.5, isn't it? 0.5 into 2 means you will get 1 here, isn't it? 0.5 into 0.5, you will get 1 here. So 1 into 22 is 22. Therefore, you get here only 22. And this is 26 here. So 26 plus 22 meters equal to 48 meter is the perimeter of the garden. So this is the answer for question number 3. And let us go to the next question number 4. So next question number 4 we have like this. A flooring tile has the shape of a parallelogram whose base is 24 centimeter and the corresponding height is 10 centimeter. How many such tiles are required to cover a floor of area of 1080 meter square? Dear student, one thing you have to very uh, clear here and to notice is that the dimension of the tile, which is in the shape of parallelogram, is given in centimeter, and the area of the floor is given as uh, unit of meter. So these things you have to be little careful. Okay. So let us see how we can do. That means how many such tiles are required to cover. See, you have to find out the area of the tile first, and we have to divide to this area of the total area of the floor. Then you will get the number of tiles, isn't it? Yes. So let us see. The solution. Area of one tile is based into height, as it is the parallelogram side, isn't it? Then we have here 24 into 10 centimeters square, that is 240 centimeters square here. Then the number of tiles required to cover the floor. The area of the floor divided by the area of one tile. One tile we get here 240, isn't it? Yes. Then area of the floor is given in meters square. Therefore, we are going to convert this into centimeter square. If you convert into centimeter square, then you will get here 1080 into 100 into 100, because 100 centimeters equal to 1 meter, isn't it? So here, or 2 times the 100 should be multiplied, because 1 meter square is equal to 100 into 100 centimeters. Okay. So because of the square, it should used to be 2 times multiplying the 100, the value of the centimeter in millimeter. Okay. This 100 for converting into the centimeter. You know that if you want to convert the meter into the centimeter, we have to multiply with the 100. But why 2 times 100 is there? Because of meter square. So meter square, if it is meter square, then 100 should be multiplied 2 times in the figure or in the value. Okay, to get it or to convert it into the centimeter. Then after that we converted, then we can go for the division now. Okay, that means the whole value is going to be divided by 24, isn't it? So you just cancel it, just two zeros, and divide the total product by 24, then you will get 45,000. So 45,000 of the number of tiles is required for flooring the particular surface. Okay, so this is the number of tiles. Okay, yes. So here also centimeter square, here centimeter square and centimeter square will be cancelled, and no more centimeter, only the number figure is there, and this figure is the number of tiles required for the flooring. Okay, so this is the answer for question number 4. Now let us go to question number 5 here. Now let's question number 5. We have the question number 5 like this. An ant is moving around a few foot pieces. Different foot pieces are the foot. Okay, of different shapes scattered on the floor. For which foot piece would the ant have to take a longer round? Remember, circumference of the circle can be obtained by using the expression c is equal to uh, yes, 2 pi r, where r is the radius of the circle. Now the diagram is given like this here. So this A, B, C are the 3 foots of the ends, where the end used to go around the foot. Okay, in the given diagram, in that track. Okay, the end used to go in track A, the track in such a way, B in this way, and C in this way. And then the question is asking that in which foot that the end will take longer, uh, longer to go around, whether A, B, C. That we are going to find out. To find out that, we are going to mark it. There is no any marking here, only just given some length here, isn't it? So we are going to mark here A, B, C, D. Okay, wherever it is necessary, so that every time the end start from A, then we add. We know that the perimeter is the the distance will be the perimeter of this track, isn't it? So if we mark A, B, C, D from A to B, B to C, or C to D, then we can add that way. Okay. So let us see the solution. So in the solution, A, B, C, D in the given figure as shown, let A be the point in each figure from where the ends start moving on the foot pieces. C is to reach the initial point after moving around boundary of its foot. Yes. So when the n is moving around the foot, so around the boundary, the track is made. So wherever you start from A, will always come back into the A. If you start from A, you will start from A like this one arc, then again come back to the A again, isn't it? But the whole track A to B and B to A like this. Got it? Here also from A to B and B to C, C to D, D to A like this. So to know about the track, to clear about the track and find out the perimeter of the track, we just mark AB or ABCD or ABC. That much. Okay, clear. So let us start. For foot piece A, distance move is arc AB, arc AB and plus BA. So that is the track or distance that move along the foot by the end. Then with arc AB. Arc AB, you know that what would be the arc AB? Arc AB is a semicircle. Circumference of the semicircle. Circumference of the semicircle is half pi r. Half pi r. Okay, clear. And AB length is given here 2.8 centimeter. That is given here. Okay, and where r is equal to 1.4 centimeter. Why 1.4 centimeter? Radius will be the half of this AB, isn't it? Half of AB will be 1.4 centimeter. Yes, you know. Then here, semicircle, the length of AB is the half of the circumference of the circle, isn't it? So half two from this half and two from this circumference will be cancelled, and you are getting here pi r. So pi r you are getting here, and 22 by 7 into 1.4 here, isn't it? Yes. Yeah, you get here 1.4 here. Yes. 1.4 is the radius. Got it. So here we have this part. Okay, this is here this part only. Okay, this one here. So now you get here 22 by 7 into uh, r means 1.5. So if you cancel 7 and 14, you will get 7 and 14, not 14 is 1.4, isn't it? So if you cancel this to 7 and 1.4, you will get 0.2. 0.2, and if you multiply with this 22, you will get here 44.4 plus 2.8 centimeter. This is not equal to, it should be plus here, okay? Plus not equal to. So you are this the whole function, the whole calculation of the once again student, this part, okay, this part again, you see 22 by 7 into 1 by 1.4, okay. So if you cancel 7 and 1.4, you get here 0.2 here, 0.2, and if you are multiplying 22, you will get here 44.4 here, isn't it? This is not equal to, this should be plus, okay, it's coming down here. So and then after we are getting here 4.4 centimeter plus 2.8, then we are getting here 7.2 centimeter here. So 7.2 centimeter is the perimeter of the track here, means total I mean round, okay, that much distance that met round by the end in foot A. Then for foot piece B here, distance moved by the end will be arc AB. Arc AB here, arc AB plus BC plus CD plus DA. You got here, isn't it? Yes. Then arc AB. Arc AB, as we know, that is half of the circumference. This is a semicircle, isn't it? Half of the circumference, isn't it? Semicircle, isn't it? Circumference is half will be given. So these two and these two will be cancelled here as before that, and after that we are having here pi r. Okay, pi r. So BC how much? BC 15. The CD how much? 2.8, and again DA will be same 1.5 centimeter, isn't it? Yes. Now these two will be cancelled. 2 here and 2 here will cancel. We have pi r. So pi 22 by 7 and r 1.4 centimeter here, isn't it? And my dear student, if you add all these three, 1.5, 2.8, and again 1.5, you will get here 5.8 centimeter altogether. So now again this part, as it is the same part here, there is 4.4 centimeters same, okay. Then if you add these two, you are getting here 10.2 centimeter again here. So 10.2 centimeter is the total distance took by the end to go around to the foot B. Okay, and for the foot C, you see a distance moved by the end. Again, arc AB plus BC plus CA. Okay, here you see diagram. Now this part will be same as is before that, isn't it? Before we have gone through, isn't it? We have already calculated here this part half of the semicircle, that then we are getting here 4.4 centimeter here, 4.4 centimeter plus plus BC. BC how much? You see BC 2 centimeter, isn't it? And AC also 2 centimeter. 2 centimeter, that means 4 centimeter both together. BC2, CA2, so 4 centimeter. So 4.4 centimeter is the half of the circumference, and 4 centimeter is the total of the BC and CA. That means it's getting here total as 8.4 centimeter. This is the total perimeter or total distance of the round made in the foot C by the end. So all of three, which is having the more distance here, that is in the foot B, isn't it? So that means the end is taking longer round in the case of foot piece B, which is having the actual length of 10.2 centimeter to go. Okay, so this is the answer for question number 5 once again, my dear student, and thank you for joining me. And here comes the end part of today's session. So with this, I once again thank you very much for joining me and watching my video. So my dear student, for today here we come to the end, and we meet again in the next video. Till then, have a nice day all of you, and once again thank you for watching this video. Thank you all. Have a good day. Bye bye.